Okay, so welcome back everyone, and let us start with today's question of the day. Today's question of the day is maximum path sum. We've been given a root of a binary tree. We need to find the maximum path sum, and the path may start and end at any node in the tree. This question has been asked in big companies, Flipkart, Google, and Facebook. The same question has been mentioned on the Leetcode platform as well as binary tree maximum path sum and in a hard category question. So let us see how we can solve this one, and let's get started. So what are some of few things we need to understand from this question is, let us highlight the things which we know. We have been given a root, we need to find the maximum path sum, and there's the tree, right? So we're going to take the second test case maybe, just for simple intuition, or maybe another simple tree. So let us say we have a tree like this, and we're going to form all the cases now. So 3, 4, and 5, and we have as 2, right? So we need to find the maximum path sum. So can we say that at any point हमें हर एक point पे जाना होगा and we will get the maximum path sum, right, for all the nodes, and उनमें जो maximum होगा we will return that, right? But there is a catch यार, यहाँ पे दो catch है. जैसे कि ये देखो 3 है, तो हम यहाँ पे सबसे पहले तो हम यहाँ पे recursion ही लगाएंगे यार, right? क्योंकि let's say we start from 1, we go to right and we go to left again and we reach at the bottom leaf node, right? So going at the bottommost part, this will contribute the 4 as sum, and this will contribute the bottommost 5, which is 5, which it will contribute the 5 as sum, right? Or let's say the maximum sum from here. So अब हम जब हमारा रिकर्जन वापस इस पे जाएगा अपने पेरेंट कॉल पे, सो हियर देयर वुड बी 2 वेज, राइट? तो जो पाथ है हमारा यार, क्या हम पाथ देखो जैसे कि 3, 4 और 5 है, राइट? सो वी कैन कंसिडर दिस एज वन पाथ, कर सकते हैं. बट इफ़ आई आस्क यू, लेट्स से 1, 3, 4 and 5, right? So can we consider this entire subtree in one path? I would say not. How come? If we start at this point, we go at 3, right? So there is a split between the path now. Either we go to 5 or either we go to 4, right? So either we take this direction 1, 3, 4, or either we take this direction 1, 3, 5, right? So I would say that at any point, or let me write it for you. I would say that at each node we need to track the split path value sum. When I say split path value, so when I started from here 1, 2, 3, I need to split the path. Either I take 5, either I take 4, right? So split path value sum and non-split path. So what is a non-split path? So this one is the non-split path example, in which we take all 3, 4 and 5 and it forms a path like this, right? And when we go to our previous parent call, then we need to return this value, right? Let us I don't know if it's making sense to you, but let us complete a dry run and it will be making sense to you in a while. So going to the bottommost part of the tree using the DFS, right? So here 4 will contribute as 4 as sum, because there is no cells beneath it, or there is no path beneath it, so we cannot even split it if you even try to. Similarly for 5, we cannot split it even if you try to, and the sum would be 5, right? Now when we go back to its parents, then this node will have the maximum, let's say one of the possible sum, as we consider this tree, and what would be the maximum sum in that case would be 5 plus 4, 9, and the current value, which is nothing but 12, right? So we need to maintain one more variable as well, let's say max sum, right, which will help us track this non-split value path at times, right? So first of all हमारा sum था 4, then it updated to 5, and then it goes on to 12, right? So this is one possible sum, you can say, one possible path sum of 12, right? But we need to check for all the possible paths as well, right? So the question is, can I return 12 to my parent call of 1? So, and can I say that this 12 will be the right sum, like the right hand side sum path for this one? I cannot. ऐसा नहीं कह सकते यार. देखो हमने डिस्कस किया था, we need to split the path. Once we come start from 1, we go to 3, then we need to take the path from either 4 or either 5, right? So in that case, there is this thing, the non-split path sum we already track, but we need to track this as well. तो इसे कैसे ट्रैक करें यार? देखो इसे हम इस तरीके से ट्रैक करेंगे कि we will take the current root plus the maximum of L comma R, right? We take हम देखें तो हम यहाँ पे कौन सा पाथ कंसिडर कर सकते हैं, हमें मैक्सिमम चाहिए टोटल वैल्यू, राइट? टोटल वैल्यू मैक्सिमम कब होगा, जब हमारा रूट प्लस एल सम प्लस आर सम मैक्स होगा, राइट? सो वी विल टेक एंड अगर हमें एक ही पाथ लेना है, वी नीड टू स्प्लिट इट, तो हम फिर ये वाला पाथ लेंगे इधर जहाँ पे एल सम मैक्स हो या फिर आर सम मैक्स हो. इन दिस केस आवर पाथ विल बी लाइक दिस 3 and 5, right? We will ignore 4 because 4 is lesser than 5. So in this case my thing would be the value which need to be returned would be 3 plus maximum of 4 comma 5, which is nothing but 3 plus 5, which is nothing but 8, right? So 8 यहाँ पे लिख रहा हूँ and this would be returned to my parent call, right? Similarly, going to the bottom of the recursion for this one, this node will have the value 2 and that to be returned to its parent call, that is 1, right? Now यहाँ पे अगेन दो सम होंगे यार, यहाँ पे अगेन से दो सम होंगे, दैट इज 12, राइट? दैट इज नॉट 12, द रिटर्न वैल्यू इज 8, राइट? बिकॉज हम 12 नहीं रिटर्न कर सकते हैं. सो 8 प्लस इट सेल्फ प्लस दैट इज द रूट एंड प्लस द left sum which is 2. So 8 plus 2 10 and 11, right? So 11 is not greater than a maximum, so we will not update it, right? So ये तो हमारा पहला केस हुआ जहाँ पे we are not splitting it. But अगर यहाँ पे इमेजिन करो अगर कोई और रूट होता है यहाँ पे इस 1 का भी, तो हम जो रिटर्न करते हैं ना वो ये रिटर्न करते हैं, माई करंट रूट प्लस द मैक्सिमम फ्रॉम ईदर साइड, दैट इज 8 and 2, 1 plus 8, 9 रिटर्न करते हैं. आई होप आई एम एबल टू मेक सेंस टू यू गाइज एंड यू आर एबल टू अंडरस्टैंड इट, राइट? दैट्स द होल थिंग. दो तीन बातें थी यहाँ पे. वन लास्ट पॉइंट जो यहाँ पे टच करना चाहिए हमें कि व्हाट इफ द नोड्स आर नेगेटिव, राइट? सो इन द सेम ट्री 1 2 3 we have, let's say, -4 and -4, right? So in this case, if you check it manually, then in this case what should be the maximum path? Just 3, right? We shall ignore this -4 and -5. So what we will do is, while tracking the non-split path sum, we will take the maximum of L comma 0, because we will be doing a recursive call for left, right? And we will track the maximum of R comma 0, and then we will take the maximum from here. That is, in the non-split path we will take the both as sum, and in the split path value we'll just take the maximum of it, right? So what will happen here is it will take as 3 plus -4 comma 0 maximum of iska plus -5 comma 0 which is maximum iska, which is nothing but 3 plus 0, that is 3, right? That is it we need to handle. So what would be the time and space for this one? Time would be O of n, because we are visiting each and every node once, and space complexity would be O of height of the tree, because that would be the maximum number of calls your recursive stack will hold, right? Please try to pause this video here and try to code this approach by yourself. Okay, let's start with the coding. So I am making one global variable first of all, int max sum, and max sum is equals to nothing but root dot data. Declaring with root dot data because ये जो 10 है root, वो भी एक max possible path sum हो सकता है, right? So that is the reason we have declared with that, and we're gonna call the function DFS root, and we say return max sum. Okay, we're gonna make a function DFS. We're gonna pass the root node, right? And if root is equals to null, that is we are hitting the leaf nodes here, or basically if there are no roots to traverse, so return 0 in this case. We make a left call, that is left max, and we take the maximum value of it to handle the negative integers. So math.max DFS of root dot left comma 0. Similarly, we have to make a right max variable, which would be nothing but math.max DFS of root dot right comma 0. Right now we will compute the max sum, or let's say the max path sum with the split. So I'm just writing with split case. So in this split case we need to track max sum is equals to nothing but math dot max our global variable comma root dot data plus left max plus right max, right? And we're gonna return the max path sum without the split case, so we'll just say return root dot data plus math dot max. We take the maximum from left call and the right call, so it would be left max comma right max. That is it. Let us compile and run, and then we can see the C++ reference. So the Java solution got submitted. Let us see the C++ reference of it, and we can submit the same solution as well on the Leetcode, so that you can just have a track of it. Leetcode पे profile maintain कर लो. There is nothing to harm. GFG पे कर रहे हो तो वहाँ पे भी कर लो. C++ कोड देख लेते हैं. So that would be your C++ code. Again, the code is successfully compiled. Let us now hit the submit button. So that also been successfully submitted. While you are at it, do check out our channel. There are a bunch of playlists and other sections which can help you in your software engineering career. So till then, keep learning, keep growing. Bye bye, and take care, guys.